Hi guys, welcome back. Welcome to this new series all about triangles. Today we're going to be looking at the sine rule, and we're going to start this off by how can we prove the sine rule. Later on we're going to be looking at what information you need for the sine rule and how can you do it step by step. So that's coming in another video. So to start off proving the sine rule, you want to draw your triangle. Now, the most important thing with sine and cosine rule is to get your labeling correct. You want to have capital letters on your angles and little letters on your side. Now, you can see from my color coding, if you've been watching for a while, you know I love to color code all of my notes, that angle A should be opposite side A. So you can see I've got them both in purple, right? So the big A and the little a are opposite each other. You can check if you've done it right by if you imagine if you were to shoot a bullet out of angle A, it should hit side A. And the same for angle C and side C and B and B. Now, the sine rule is sine A divided by A equals to sine B divided by B equals to sine C divided by C. We're going to start by proving off that sine A divided by A is equal to sine C divided by C. So we're going to take this bit out of the equation for now and just start with that. So this is our RTP. If you're wondering what RTP stands for, it's required to prove. So we're going to start out with sine A divided by A equals sine C divided by C. If you want to see the much prettier, more beautiful notes, check out the website. So to do this, what we're going to do is you're going to run a perpendicular. So a perpendicular is a line that makes 90-degree angle with another line. You could have lots of perpendiculars to B. So as long as it forms a 90-degree angle there, it's a perpendicular. But we're going to move ours specifically so it's 90 degrees and it goes through B. So what we've done is we've taken our triangle and we've split it up into two right-angled triangles. So I'm going to color them in so you can see them. So we can call this one triangle 1, it's over here. And we've got a second one over here. So one big triangle is now broken down into two smaller right-angled triangles. So let's look at the first triangle here, this green triangle here. What I'm going to say is you have to remember your SOHCAHTOA. So sine angle is equal to opposite side divided by hypotenuse. I'm just going to call that hype for short. I usually just write it like this, OPP over hype. Now, you need to know or refresh from IGCSE or GCSE how to find your hypotenuse. Your hypotenuse should always be opposite your right angle. So in triangle 1, it's going to be A. Now, we're going to call this perpendicular that we've put here H. So let's call that H there. So working in triangle 1, we're going to say sine, the angle is going to be C. The opposite's going to be H, and the hypotenuse of triangle 1 is going to be A. Now I'm going to solve this for H, so I'm going to make H the subject. This is a divide by A, so when I move it to the other side, I need to multiply by A. So this would be A times by sine C is equal to H. So we're actually just going to repeat that exact process step by step so we can keep that here. I'm going to put a green box because this all came from the green triangle. We're going to repeat that exact process here in triangle 2, the yellow triangle. We're going to start out with our formula. I always write my formula first. So sine angle equals opposite over hype. So in this case, in triangle 2, it would be sine A equals the opposite. So opposite would be opposite angle A, which would be H again, divided by the hypotenuse, which in this case would be C. So again, I'm going to make h the subject of this second equation by taking this divide by c and moving it to a times by c on the other side. Now, this is all coming from my second triangle. So what I've done is I've taken my big triangle, split it up into two right-angled triangles. The line that's dividing them is called h, and I've made two separate equations for h. So I've got h equals to over here and h equals to over here. Now it makes sense that if this is equal to h and this is equal to h, they should be equal to each other, right? So I can say a sine c equals h equals c sine a. Now I can get rid of this bit in the middle, and it must therefore be true that a sine c is equal to c sine a. If I go look back at my RTP, what I was required to prove, I have two fractions. So I have all the a's together and the c's together. So all I need to do is move this divide by c over here and this divide by a over there. And I've got the first part of the identity. Now, you don't need to repeat this process again to get the sine b in the formula. So we're down to the part where we've got sine a divided by a equals to sine c divided by c. And to get the third part, or the sine b divided by b, you could repeat the process making h perpendicular to a, and then you'd be left with sine c divided by c equals to sine b divided by b, right? So then you would say similar. It's not necessary to repeat the exact same workings dividing up the triangle again in a different place, for example, like here. It's sufficient to say that similarly you could derive that sine b divided by b would be equal to sine c divided by c, and you're done. In the next video, I want to look at the ambiguous case of the sine rule and why that occurs, so stay around for that. And we're also going to be doing in this series the proof of the cosine rule, so lots of good stuff coming up. Check out the website for the more beautiful detailed notes, and I will see you in the next one. Bye for now.